You with Chapter 4, Lesson 10, to be continued, right? Simplify algebraic expressions. Oh, we're going to take a step back. We are not going to be working on equations. We're not going to be trying to find some solution. We're simply going to simplify algebraic expressions. Now, I want you to think about these words over and over and over and over and over again as we go through the lesson. Groups and like terms, groups and like terms. Are there any groups? Are there any like terms? Are there any like terms or any groups? Here we go. Pause if you wish, whatever the assignment number was. Check your answers. Come on back when you're ready. Go ahead and pause the video. Come on back. All right, folks. So, yes, we have been doing equations. We've been doing equations with positives and negatives. However, eventually we're going to get to, multi-step equations. I would argue that today's piece then is crucial. So imagine that the equation is not there. Can we take this expression and simplify it down? 1, 2, 3, 4 terms with parentheses. Can we make our lives simpler? Because if we do that, we can use that idea to simplify a multi-step equation, and now it becomes a two-step equation. So that's the idea for today. We're going to imagine there are no equations for today. We're going to focus on expressions. How do we simplify it and make our lives simpler and easier? All right, go ahead, pause the video, whatever the assignment number, whatever the date, pause the video, title your paper for some notes. Come on back when you're ready. All right, what is the distributive property? Distribute, look at that root word, distribute, give to everyone equally. We multiply each term inside the parentheses by the number that's outside the parentheses. Now, where have we seen this before? We have distributed before in order to make multiplication easier. Now think about 5 times 23. What if you just did 5 times 20 and then 5 times 3? And mentally, 5 times 23, you could do this mentally if you use the distributive property. 5 20s is 100, 5 3s is 15. Naturally put them together. Okay, Mr. Callan, but what if the terms inside are not all numeric? What if they are algebraic? How can we use the distributive property with algebraic expressions? Let's think about this. 3 times parentheses x plus 5. Remember, if you don't see anything, it does mean multiply. Strategy number 1. Think about multiplication as repeated addition. If you have 3 groups of x plus 5, well, you could rewrite that. X plus 5, another x plus 5, another x plus 5. In turn, you could even draw it out. Here's an x plus 5, then there's a second group of x plus 5, then there's a third group. But why write 3 groups of x when you could simply write 3x? Combine your like terms. And why write 3 groups of 5 when you could just write 15? That, ladies and gents, is why we use the word simplify. We have 1, 2, 3 terms up there, and we now only have 2 terms. We have parentheses at the beginning, and now we have no parentheses. By the way, can we combine those into 18? No, you cannot combine those terms. Little phone distraction there. 3x plus 15, one of them is a missing number. One of them is not. One of them is a constant term. So that is as simple as it gets, ladies and gents. Now, strategy 2 is using the distributive property. And that's where we can draw these nice little groups, draw these nice little arrows. 3 times x is 3x, 3 times 5 is 15. Think about it. When would it not be a great idea using repeated addition? Well, imagine if instead of saying 3x, go ahead and pause your video if you want. When would it not be an idea? Come on back after you've thought for a few seconds. What if instead of saying 3 groups that said 23 groups or 123 groups? Would you really want to sit there and write x plus 5 over and over and over again? Probably not. But you could simply multiply 123 times x, 123 x's, 123 times 5, 500, 600, 615. and be done like that. So that is the power of the distributive property, saving you time from repeated addition. All right, what do we do if there are more terms? Well, here we still have 5 groups, so I'm going to go ahead. Off to the side, I'm going to write there's 3x and 2y and negative 5, and 3x and 2y and negative 5, and 3x and 2y and negative. Ultimately, we need 5 groups of those. All right, so what is 5 groups of 3x? 3x, 6x, 9x, 12x. I believe I'm seeing 15x's. What about 5 groups of 2y's? 2y, 4y, 6y, 8y, you guessed it, 10y's. And last but not least, what about 5 groups? I myself am a fan of changing that to add the opposite. We got negative 5. You may write subtract 25, or you may write add the opposite. Again, to bring it back full circle, can we combine X terms and Y terms? No, that's like 5 envelopes of money, and this is 10 purses of money. I don't know. But the point is, those are not like terms because the variables are different. The mysterious numbers are different. Can we combine 25 with anything? No. That's simply owing $25. But these are unknown amounts. So this, ladies and gents, is as simple as it gets. 15x's plus 10y's plus a negative 25. But at least we don't have the parentheses and we have one less term. Onward we go. Pause your video if you wish. Complete these 4 by simplifying and come on back when you're ready. All right, folks, you guessed it, 7 times y, 7 y's. 7 times 3 is 21, so we end up with 7 y's plus 21. 8 groups of m is 8 m's. 8 groups of negative 1. It's going to be negative 8. Now you may write subtract 8, or you may write adding a negative. Either one of those would be acceptable on a quiz. After all, subtracting $8 is the same as adding $8 in debt. 5 groups of 4x is 20x. 5 groups of negative 5 is negative 25. Again, you may write subtraction, or you may write adding the opposite. Now, what about this guy? How do you take the opposite of 9 groups? I want you to think about this. Let me drag a few. I'm going to run out of space, so let me just put a dot here. Now, you might be tempted to say that 9 groups of 4 is 36. However, we do have that opposite. The opposite of all those positive 4s turn to negative 4s. Therefore, 9 groups of 4 is 36, but the opposite of all those positives, it will be negative 36. Now keep on going. 9 groups of 2n's, you might be tempted to say 18n's, but the opposite, again, the opposite of all those positives turn into negatives. And so we end up with negative 18n's. Not a problem with this answer, folks. I'm trying to challenge you. I'm trying to get you ready for algebra in algebra class. They will always write the variable, almost always write the variable term first and the constant term second. And yes, you may also choose to write that as add a negative. But again, it's kind of like saying hello, Cal and Tim instead of Tim, Cal. I mean, Cal and Tim, that's me. It's just not the best way to write it. So we really do want to try to put the variable term first in front of the constant term. All right, what if the expression is bigger? So let's go ahead and do this one. 3 groups of x is 3x's, and 3 groups of 3 is 9. That, ladies and gents, is the distributive property. At this time, I'm thinking to myself, but I have several x terms. Now, some of you will do these parts in your head. In fact, you might even skip steps 3 and 4 and go on to the simplified expression. I'm going to use the distributive property, which says, as long as we're talking addition, that you may change the order and still have the same sum. So I'm going to reverse the positive 9 and the negative 7x. Now at this point, 3 and negative 7 makes negative 4x's, and since you cannot combine x terms with constant terms, that is as simple as it gets. Now look back at the top. We had 1, 2, 3, 4 terms. We got some parentheses, and we have simplified it down to 2 terms with no parentheses. That, ladies and gents, is what the word simplify means. Now again, to repeat myself, you will not be able to solve. There's no equation here. There's no way of finding that missing piece. It might forever be missing, but at least we have simplified that expression. All right, so worksheet is on the online agenda. If you want, I will do a few problems with you, noticing that anytime we're dealing with parentheses and expression, you want to make sure to distribute whatever is on the outside to everything on the inside using multiplication. So here's what I mean. Let me go down to number 5. So 4 sets of 6a is 24 A's. 4 sets of 4 is 60. But wait a second. Hold on, Mr. Cowan. First of all, I'm a fan of changing subtraction to add the opposite. And speaking of, we do have that opposite symbol there. See, the opposite of all those positive A's, I'll show you a picture in a minute, would be negative A's. And the opposite of all those negative 4's. Now look, I suppose you can write that if you want, but I myself am a fan of just simply saying, look, subtracting a negative is the same as adding a positive. So that would be highly recommended to just write negative 24A's plus a 16. Now, I would like to draw this, but I'm not going to allow anyone in my class to draw number 5. You need to pick 2 different numbers. I'm going to draw number 5. Now, number 5, we had 6 A's and another negative 4. All right, let me go here. I'm going to put some infinite cloner on this, make my life a little easier. So we need 6 groups of these. 1 group, 2 groups, 3 groups. Scratch that, Mr. Cowan. That says 4 groups of 6A's. My apologies. So 1 group, 2 groups, 3 groups, 4 groups of 6A's. We also need 4 groups of this negative 4. So there's 1 group, 2 groups, 3 groups, and 4. There you go. Now, some people even go ahead and draw this. I find this a little confusing, but it is nicer to be able to see the groups. Now, at this point you say, that does not match up because I haven't yet done the opposite. We need the opposite of all those positive A's. So every one of those A's, every one of those 6 A's turns into negative. And the opposite of all those negative 4's turn into positive 4's. The opposite of subtracting 4's becomes adding 4's. So look at my answer right now. I have a whole bunch of negative A's, in fact, 24 negative A's, or negative 24A. And I've got a whole bunch of positive 4's, in fact, 16. And as you will notice, that does match our answer. So you draw groups repeatedly. I'm going to put that disappearing ink back in. There is my first group, my second group, and my third group, and my fourth group. And you have to be careful if it gives you an opposite symbol. All right, at this point, I would encourage you to pause the video, complete the rest of page 1, and I will show you answers for the rest of page 1 momentarily. Pause your video and come on back when you're ready to check the front side. So 5 groups of x, 5 groups of 12, that's going to end up being 5x plus 60. 3 groups of 6, 3 groups of 2y's, and yes, you may rewrite that with the variable term first and the constant term second. Now careful with number 3, which has that opposite symbol. So the opposite of all those positive turns negative. The opposite of all those positive turns negative. We end up with negative 6x's and a negative 16. Yes, you may write that as subtraction if you wish. Number 4, 7 groups of 2b's, 14b's, 7 groups of negative 3, negative 21. And number 6, which I hope you did not choose to draw, because we have 10 groups of 3m, negative 30m. We have 10 groups of 11. And yes, the opposite of those positive ends up negative. The opposite of subtract, or you could say the opposite of negative 11's, turn to positives. There's no need to write minus a negative 110 when you could simply write plus a positive. Pause, rewind if you need to, go back through it. Let's go to the back side. I'm going to do number 8 with you. Imagine drawing 3 groups of 6, that'd be 18, and 3 groups of 2x, that would be 6x, but there is that old opposite symbol there. So the opposite of all those positives should be negative, and the opposite of all those positives should also be negative. So we end up with a negative 18, negative 6x. Notice the 12 is not in the group, so don't multiply 3 times 12. This 3x is not in the group, and I myself will change subtraction to add the opposite. Now at this time, some of you like to underline your constant terms. You like to box in or circle in your variable terms. Others of you might rewrite it. As long as it's an addition expression, you can change the order and have the same sum. So if I were to combine negative 6x's with negative 3x's, you're saying, hold on, Mr. Cowan, there's no zero pairs. Put all those together. Negative 9x's. Meanwhile, negative 18 and positive 12 will have zero pairs. More negatives left over. In fact, it's going to be negative 6. So final answer for number 8, negative 9x plus a negative 6. Yes, you may write that simply as subtraction if you prefer. If I were to graph those, if I were to draw that out, I'm going to go ahead and draw out 3 groups of 6 plus 2x. So 3 groups of 6, well, let's just do 6 and then 2x. And I'm going to go ahead and I'm going to clone those a few times because we need not 1, not 2, but 3 groups. And then we take the opposite. All those x's turn to negative x's, and all those plus symbols will turn to minus. So there I have 3 groups of 6 plus 2x, and I had to take the opposite of all those positive 6's and the opposite of all those positive x's. Meanwhile, 12, there is no, I'm going to do this in blue. 12, it's not in the group. We don't take the opposites. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have 3 negative x's I'm going to pop in at the end. Okay. Notice that's a whole lot of zero pairs. So I'm going to very lightly cover those off. And there are no zero pairs of negative x's. So I'm seeing negative, nope, Mr. Callan, negative 9x's. And I'm seeing 1, 2, 3, 4, negative 6 left over, which of course you could rewrite with the variable term in front, the minus 6 at the end. You could even change that, and it does match up. Whew, rewind, go back through it. What did Mr. Callan draw? Why did he draw it? You're going to be drawing your own, and you're not allowed to draw number 8 because, well, that's not going to be very helpful to you. All right, so pause the video. Come on back when you're ready to check these answers, please. Number 7, you should end up with, whoops, my bad, 14x's plus 14. We did number 8 already. Number 9, in the end, simplified down to 6x's and a positive 20. Number 10 will be 27y's and a positive 20. Notice those? That's a whole bunch of positives. So let's mix it up a little bit. Careful with number 11. That's going to have a negative 5 and a negative 6. Anyways, final answer is going to be 15x's and a negative 56. Number 12, it's going to be positive 2x's and a positive 44. All right, folks, make sure you're drawing something, and then you may go on to your homework. Notice it is the same page as the previous assignment. Now we're focused on evens. You won't be able to check any of those in the back of the book. So make sure you're checking it using your algebra steps. Take your time, do well, folks. Let's grow. See you.